Hi there, it's me, Tudanax, and today we'll be diving into differentiation using the chain rule. If you're ready to level up your calculus skills, let's go. The chain rule is a technique used when you're differentiating a composite function. That is, when you have a function inside another function like this over here. The formula is simple. When you differentiate your composite function, you get f prime of g of x multiplied by g prime of x. So in other words, you simply take the derivative of the outer function, then you multiply it by the derivative of the inner function. It's simply like peeling the layers of an onion. Outer first, then the inner. And also note that when you differentiate the outer function, the inner function remains exactly the same. It's only when you multiply by its derivative where you see some sort of change occurring. Let's try out a few examples. Let's say y is equal to 3x plus 5, all of that raised to the power of 2. So when you differentiate, first we have to deal with the outer part, right? So in this case, or our step 1, we need to first deal with the outer function. This is going to be our step 1. And when we do that, when we differentiate that, we're going to get 3x plus 5 to the power of 2 minus 1. Notice that I'm not changing, or I haven't changed the inner function, because we first need to peel the outside and then we go into the inside. And in this case, when you differentiate this using the general differentiation rule, it's going to end up simplifying to 3x plus 5 all to the power of 1. So that's for the outer function. And step 2. When we differentiate the inner function, we have 3x plus 5. And when we differentiate that, we're simply going to get 3. Because the derivative of a constant is 0. And the derivative of 3x is simply 3. And that is what we have. And when we put everything together using the formula that I had shown earlier, the derivative for composite functions, or using the chain rule, is simply the derivative of the outer function multiplied by the derivative of the inner function. And using our outer function, we have 3x plus 5 multiplied by the derivative, which is our 3 over here. This is the derivative of the inner function. This is the derivative of the outer function. And when we simplify everything, we get 3x plus 5. And notice over here that this is still our g of x. This is still our g of x. It's still our inner function. It does not change when we differentiate the outer. So first you differentiate the outer, leaving the inner the same, and then afterwards you multiply it by the derivative of the inner function. And that's how it works. And there you have it. Nice and simple. Now let's make it a bit more interesting. Now let's say y is equal to sine of 4x squared plus 2x. And using the same methodical approach, we lay out our outer function. And in this case, our outer function is just sine of something, right? And when we differentiate that, we're going to get cos of something, right? And that something is simply our 4x squared plus 2x, right? That's our outer function. And once we've peeled out or differentiate the outer function, we move on to the inner function. And in this case, our inner function over here is simply 4x squared plus 2x. And when we differentiate that, we get 4 times 2, x to the power of 2 minus 1 plus 2. Because remember, using the general differentiation rule, the exponent comes down, you multiply it with the coefficient, which is 4, and then afterwards you subtract 1 over there. And that's what we have over here. And when we simplify everything, we get 8x plus 2. And again, step 2, using the formula I'd shown earlier, where we have f prime of g of x multiplied by g prime of x, right? So the derivative of the outside function is simply cos 4x squared plus 2x multiplied by the derivative of the inner function, which is just 8x plus 2. And notice again, our g of x, or our inner function, has not changed when we first peel out the outside or when we first differentiate the outer function. It only changes once we differentiate the outer function and we multiply it. All right. And there you have it. It's easy when you break it down. And that's the chain rule in a nutshell. With practice, it will become second nature. Hence, here are extra problems for you to try out. Leave your answers in the comment section or email me at tutornax.success@gmail.com. Don't forget to like, share, and subscribe for more videos. See you in the next one with me, Tutor Nax, simplifying success one question at a time.